All right, let's talk about a term you hear thrown around all the time, big data. Today, we're going to break down exactly what it is, why it even exists, and how it's quietly powering everything from your Netflix queue to your banking app. Let's dive in.
First up, I want to start with a simple question to get us thinking. You've got an app like Instagram, with billions of photos, videos, likes, messages, you name it. Why can't you just run the whole thing on a tool we all know, like a giant Excel spreadsheet?
And there's your answer, right there. The digital world just exploded. And the data it created became so massive, so fast-moving, and so chaotic that our good old traditional tools, well, they just couldn't keep up. This is the core problem that big data was born to solve.
So, before we can really define what big data is, we have to understand the different kinds of mess we're actually dealing with. Let's take a look at the three main types of data that make up this digital flood.
Okay, this table breaks it down perfectly. Over on the left, you've got structured data. Think of this as the neat and tidy stuff. Excel sheets, bank statements, everything in perfect rows and columns. In the middle, there's semi-structured data, kind of like an email. It has some organization, right? A sender, a subject, but the body of the email is just free-form text. And then, on the right, you have the biggest challenge of all, unstructured data.
This is the wild stuff. Instagram posts, videos, audio files, you name it. And here's the kicker, the reason this all matters so much. As you can see from this chart, about 80% of all the data in the world today is this unstructured stuff. It's the biggest, messiest, and by far the hardest part of the entire problem.
So, what do we do about this 80%? How on earth do you manage a data explosion that our old tools just can't handle? Well, the answer, of course, is big data.
I absolutely love this analogy because it just clicks. You know, a traditional database is like your local corner shop. It's great, it's organized, it handles a predictable amount of stuff. But big data systems, they're like those massive, sprawling Amazon warehouses, built from the ground up to handle an unbelievable volume and variety of items, all arriving and shipping out at lightning speed. And here's the more, textbook definition. Big data refers to data sets that are so enormous, so complex that the old-school database systems, the ones that need that neat structured data, they just break. They literally were not built for this kind of scale or this kind of mess.
But what actually makes data big? It's not just about the size. The industry uses 4 key characteristics to define it, and they're known as the 4 Vs. Let's break them down one by one.
First up is volume. This is the V everyone thinks of first, the sheer size of it all. And we're not talking gigabytes anymore. We're talking petabytes and exabytes. To put that in perspective, Facebook is dealing with billions of messages and over 350 million new photos every single day. That is volume. Next, you've got velocity. And this is all about speed. Data isn't just big, it's being created at an incredible rate. And a lot of the time, you need to analyze it instantly. Think about your credit card company spotting a weird transaction and blocking it just seconds after it happens. That requires processing data in real time. That's velocity.
The third V is variety. And this goes right back to the different types of data we talked about. A true big data system has to handle everything all at once. Structured transaction records, semi-structured web logs, and completely unstructured videos and audio files, all flowing into the same system, ready to be analyzed together. And finally, veracity. This one is so important. It's all about quality and trust. Is the data you have accurate? Is it reliable? I mean, if you're trying to figure out what people think about a new product from social media, you have to filter out all the bots, the typos, the sarcasm, just to get to the truth. High veracity means your data is clean and you can trust the insights you get from it. So we know what big data is, and we know about its 4 Vs. But how does it actually work? The best way to picture it is like a pipeline, or maybe a factory assembly line, that takes all that raw, messy data and turns it into something incredibly valuable.
From a bird's eye view, this pipeline has 4 main stages. First, the data gets collected or ingested from all its different sources. Then it's put into this massive, distributed storage. Next, it gets sent to processing, where all the heavy-duty analysis happens. And finally, the results go to visualization, where they're turned into charts and dashboards that a human can actually understand. Now, don't let this diagram scare you. I know it looks a little complicated, but it's just our factory assembly line with some real-world tools plugged in. You can see the raw data flowing in from the left, from stuff like sensors and weblogs. It gets stored, then processed by powerful tools like Spark, and finally pops out on the right as a clean, simple dashboard for someone to make a smart decision.
Okay, for anyone studying this stuff, lean in and pay close attention to the slide. This is a huge exam topic. The analytics lifecycle is often broken down into these 5 specific phases: collection, cleaning, processing, analysis, and visualization. That exact sequence is super important, so it's a great one to remember.
All right, we've covered the what and the how, but now let's get to the most important question of all. So what? Why does any of this actually matter to you?
Because big data is running in the background of your life every single day. It's how Amazon seems to know exactly what you want to buy next. It's the engine behind Netflix's spookily accurate show recommendations. It's being used in healthcare to predict disease outbreaks, in finance to stop fraud in its tracks, and on social media to figure out exactly what customers really want. It is everywhere.
So we've gone from a simple spreadsheet all the way to the massive digital engines that run our modern world. We've seen that big data isn't just about size. It's a completely new way of finding hidden patterns in the chaos. So the real question isn't just what is big data, it's now that we have this power, what problems are we going to solve with it?